Hi everyone, today we are going to talk about diffraction of wave. So what is diffraction of wave? Diffraction of wave is the spreading out of wave when travels through a gap or move around an obstacles. So a gap means like there is an opening between something, and obstacles is like something that is blocking the way. And diffraction of wave can happen in water, light and sound wave. Next is about the phenomenon of diffraction of wave. So for example, the wavefront of the seawater changed from plane wavefront in region A to circular wavefront in region B. So you can see that region A is a deep area, so the wavefront is bigger. And when the seawater passes through a small opening, the shape becomes circular shape that you can see in region B. So this shows that the sea wave spread out while propagating through the gap in the embankment. Next, I'm going to talk about the diffraction of wave in water. Water wave diffraction means the amount of the wave that bends depends on the size of obstacles and also the opening. So, as you can see the diagram on the left, there is a small obstacles, means something there is a blocking. Starting, you will see that there is a plane wave. When the wave hit the obstacles, you can see that the wave bend to other sides and there is no wave in the center. And the diagram on the right is about the small opening. When starting is also a plane wave, the wave will only passes through the opening because the upper and lower part of the water wave cannot pass through. So the wave passes through the opening and spread out. Next is about the effect of diffraction. The effect of diffraction is obvious only if the size of the gap or the obstacles is small, wavelength is long enough, and the frequency of the vibrator is low. So you can see that the effect of diffraction is more obvious around small obstacles, and the effect of the diffraction is less obvious around large obstacles. Next is about the relationship between the size of the slit, wave pattern and wavelength. The diagram below shows the wave pattern before and after they have passes through two different slits. So the first one is the narrow slit. The second one is the wide slit. The wavelength of the wave before and after passing through a small slit and a large slit are the same. When the wave passes through a slit, so in conclusion, the larger the bending of the wave will be. And the larger bending of the wave shows the wave are diffracted more. So in conclusion, when the wave passes through a small slit or a small obstacles, the wave bend or spread more and the effect of diffraction is more obvious. And when the slit or the size of the obstacles increase, the effect of diffraction is less obvious.
You can see this video. This video shows that when there is a large gap, the circular will only circular at the sides and is less curved and also less diffractions. While for this video, the gap is a bit wider, still circular but is less and it's open wider. While for this video, there is a small gap, so it's more circular, open more wider, and also more diffractions. Now we'll move on to the effects of the diffraction on characteristic of wave. There are 6 characteristics of wave. For the first one, wavelength. The wavelength does not change because the wave speed does not change. While for the second one, frequency does not change because there is no change to source of frequency. For third one, speed does not change because there is no change in medium before and after diffractions. So you need to remember 3, which is that does not change. First one, wavelength, second, frequency, and third one, speed. For the amplitude will decrease because the wave energy diverges and spread out to a wider region. For the direction of propagation, it will change from one direction to many directions because the wavefront spreads. For the energy will decrease because the energy spreads. Next, we will move on to the effects of diffraction of wave. There are two factors that affect the diffraction of wave. The first one is the slit size and the second one is wavelength. As you can see, the first diagram, the gap is bigger than the lambda, so the spreading of wave is less significant. While for the second diagram, the gap is smaller or equal to the lambda, so the spreading of wave is more significant. For the second factors, when there is a short wavelength, the spreading of wave is less significant. When there is a long wavelength, the spreading of wave is more significant. You can see this video shows that when there is a short wavelength, the spreading of wave is more curved. And for the long wavelength, you can see the direction of the diffraction of wave. Now we will move on to the diffraction of light. The diffraction of light wave occurs when the light passes through a small slit or small pinholes. The wider middle bright fringe show that the light wave diffracted after passing through a small slit. And when they pass through this slit, the light will diffract. After diffractions, the light will open wider. That means that the screens will full of the light, but the light they got a different color. Normally, we will say bright or dark. The center one is sure is the wider one because the light goes red, and the other should be bright dark like that. And when you see the diagram, the center become wider. Sure, this is a phenomena of diffraction of light wave. Then the rest they are not the same size. Every fringe the size is not the same. The only sure is the center should be a bright fringe. If the slit become wider, the diffraction pattern will become less obvious. And as you can see, this is the diffraction patterns through pinholes. And for the next one, this is the diffraction pattern through the single slit. The light wave have shortest wavelength compared to water and sound wave. Therefore, to diffract light, the gap need to be extremely small. The maximum diffraction occurs when the size of the gap is smaller or about the same size as the wavelength.
Now is diffraction of sound waves. You can refer to the diagram below. A listener stands on position Y so that the radio is beyond his vision. The listener is able to hear the sound of the radio, although it is behind the wall. It is because the sound of the radio spreads around the corner of the wall due to diffraction of sound. The sound waves can be diffracted easily because they have the longest wavelength compared to water and light. When the wavelength increases, diffraction increases. This is the diagram show diffraction pattern of sound wave. Next will be diffraction of waves in daily life. Diffraction of water waves produces calm of water regions. Diffraction suitable for docking of ships and water recreational activities. Holograms produced by effects of diffraction of light are used as safety features on bank cards such as debit cards and credit cards. Infrasonic waves produced by bats have long wavelength to facilitate long-distance communication between elephants. The last part will be questions. Question 1. Figure 5.48 shows water waves approaching a gap in a ripple tank. A. Draw the wave pattern formed to show the wave phenomenon that occurs. This is the answer of A. B. What happens to the amplitude of water waves after passing through the gap? The answer is amplitude of water waves decreases. This is because the waves spread out to a larger region. Questions 2. Figure 5.49 shows an audio generator placed near the corner of a high wall. 3 students, A, B, and C, are standing around the corner. The audio generator can produce sounds with different pitch. A. State one factor that affects the pitch of the sound. The answer is frequency. B. When a high-pitched sound is generated, only student A can hear the sound clearly. When a low-pitched sound is generated, all 3 students can hear the sound clearly. Explain this situation. The answer is, high-pitched sound has high frequency but short wavelength. Sound waves with short wavelength have less diffraction around the corner. Therefore, only student A can hear the sound clearly. Conversely, a low-pitched sound with long wavelength can be diffracted with more spreading around the corner. Therefore, all 3 students can hear the sound clearly.